So now that we've seen what a function is and what function notation is, we've had some pairs of numbers that are just connected for no particular reason. But now we want to see how we can represent functions as equations and graphs. All right. So we've seen that functions can change one set of numbers, the domain, into another set, the range. They connect these two. We're going to be looking at 4 types of functions in this class: quadratic, radical, exponential, and logarithmic. Okay? So let's kind of dabble in these a little bit here, and we're going to see how we can make a graph of an equation here. All right? So we have, here's a function. This should be something familiar to you from previous classes. We might write this as y equals 3x, or L of x equals 3x. So here we just give it a name. We give it a name L. But really this is just the same as saying y equals 3x. Okay? So if we want to find some values, like if we want x to be -1, we're looking for L of -1. In other words, we put -1 in here. What do we get? 3 times -1 is -3. If we plug in 0, we get 3 times 0, which is 0. And if we plug in 1, we get 3 times 1, which is 3. 3 times 2, which is 6. Plug in 3 for x, you get 3 times 3. Plug in 4, we get 3 times 4, that's 12. So this is what we call a table of values. So when we started with an equation, L of x equals 3x, we made it into a table, and now we can take that table and we can graph them here. All right. We'll kind of graph at the same time. So we have our axes here, right? We have an x-axis and a y-axis. And y is the same as saying f of x, or in this case, L of x. All right, this is our function L of x. So see, instead of calling all these y's, we can have different equations, and we can kind of give them names. We can call this one L, call this one Q, call this one R, E, just like parents give their kids names. Well, here we've got different names for these equations, okay? So we can talk about them differently, all right? And then we're going to graph these points. So we got an x and a y coordinate. -1, remember, so this is the point -1, -3. Remember, the x coordinate comes first and the y coordinate is second, okay? Or we might say this is x comma f of x, f being a general name there, okay, L in this case. So -1, -3, that would be the point right down here. So, okay, then we can graph 0, 0. Then we got 1, 3. And 2, 6. And 3, 9. And then 4, 12 is off. Okay, now we just pick some numbers. So if we were graphing by hand, we're going to pick some x values. We just pick some random ones here, plug them in, and we see a nice pattern, right? This is a line, right? So this is a linear function. And this is one that hopefully you've had experience with in previous classes. If you've never seen a linear function, then you might want to take Math 65 first, okay? But if you took Math 65 or a class similar to that, then you should be pretty good at linear functions. Well, here we have another function. This is q of x equals x squared. Okay, so we can make a table of values the same way. Plug in -1, -1. Plug it in for x, we're going to get -1 squared. It's got to go in parentheses. -1 times -1 is 1. Then we got 0, 0 squared. Then we plug in 1, 1 squared is 1. 2 squared. Okay, you might, fill it in there. What's 3 squared? What's q of 3? Well, that's 3 squared, 9. Q of 4, plug in 4, 16. Okay. There might be a couple other useful ones while we're at it. Let's go back. Let's try -2 while we're at it. What's q of -2? Well, that would be 4 also, right? Because that's going to be -2 squared, which is 4. Okay. And negative 3, while we're at it, this would be negative 3 squared. Negative 3 times negative 3 is 9. So if we plot those points, we have negative 1, positive 1, 0, 0, 1, 1, 2, 4, 3, 9. And then we have 4, 16, which is off the charts. We have negative 1, 4. No, I'm sorry, negative 2, 4. Negative 3, 9. Okay. Do we see a pattern? We do. Now, we could plug in between values. You could plug in a half. And if you plug in a half, it's going to be right in between here. If you plug in 1.5, it's going to be right, and it's going to be somewhere right about here. Okay? So we could plug in decimal numbers, but it just gets more complicated. So the whole idea of what we're doing here is we're plugging in nice, neat numbers to find the pattern. And we got an idea. It's going to follow this nice, neat pattern. It would fill in that curve, and this is what the curve will look like. Okay, this is a quadratic function. It's not a line. It's a shape we call a parabola. But this is our quadratic function, q. This q of x, this x squared, is a quadratic function. That'll be chapter 9 that we're going to study that. Okay, then we have a square root function. Well, what if you plug in negative 1? Can you take the square root of negative 1? Okay, remember a square root means what number multiplied by itself makes negative 1? Well, there is no such number, right? So this doesn't exist. In fact, can you do the square root of any negative number? Like, what's the square root of negative 4? Is it negative 2? No, negative 2 times negative 2 is positive 4. So this does not exist. We say D and E does not exist. Okay, so you actually can't square root any negative numbers. Okay, but we can't square root 0, because what number multiplied by itself gives you 0? Well, the square root of 0 is 0. What's the square root of 1? It's 1. And now we can pick any x values we want. So if you were making this table, you might pick something, I don't know what the square root of 2 is. I don't know what, the square root of 2, what number times itself makes 2? Well, we're going to talk about that in our next lesson. There is a number. It's about 1.4, okay? But the square root of 2 is a decimal number. So we don't want to mess with that when we're just looking for a graph. Square root of 4, we do know that's 2. 2 times 2 is 4. Square root of 9, oh, here's a typo. That should be a 9 there. What's r of 9 would be the square root of 9, which is 3. R of 16, that should be a 16. We're plugging 16 into the function. Square root of 16 is 4. Okay? Well, now we can graph these points. Okay? 0, 0. Okay? 1, 1. 4, 2. 9, 3. And then 16, 4 is going to be off the charts. Okay? So there's our function there. Okay. Now, notice these functions go off. Here we put arrows on the end because it continues going up. It continues going up. This is going to continue. We're not going to put an arrow over here because this does not continue to the left. We can't come down here because those would be negative x values. It starts here and it goes off to the right. We could keep going to the right. You could put bigger positive numbers in, but you can't put negative x values in there. Okay. So this is our square root curve, or a square root is also called a radical curve. Okay, but specifically, it's a square root. It's the one we just graphed. Okay, and then we got one more function. Now that by the way, this radical, this will be the topic of function. Of chapter 8. Okay. And then we have one more that will be from focusing on in chapter 10. And that's like 2 to the x power. Okay. Well, let's see. I'm going to go backwards here. What's 2 to the 4th? Let me erase this here. Okay. Yeah, we'll just do it here. Okay. So 2 to the 4th is, that means 2 times 2. 2 to the 4th means 2 times 2 times 2 times 2. Which is 2 times 2 is 4. 4 times 2 is 16. I'm sorry. Let's try that again. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay? If we just have 2 to the third, well, 2 to the third is going to be 2 times 2 times 2. That's just 8. 2 to the second is 4. 2 to the first is 2. Okay, now let's look at this pattern here. Okay, I'll put this in here, 2 to the third. Okay, what's happening as we go backwards from 16 to 8 to 4 to 2? Can you tell what's going on when you go backwards? We're dividing by 2, right? 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. Well, 2 to the 0, what's 2 to the 0? It has to be divided by 2, and it's 1. Interesting. 2 to the 0 is 1. Okay, in fact, we're going to find out that anything to the 0 power is 1. Okay, and then, oh boy, what about a negative power? If we continue this pattern going backwards, well, we got to divide by 2, divide by 2, divide by 2. What's 1 divided by 2? It's a half. Okay, so we'll dig into this more when we get into chapter 10. Okay, but we got some numbers here. We've got negative 1, 1/2. That point is right down here. 0, 1, 1, 2, 2, 4, 3, 8. Again, we're just, I'm going kind of quickly here, but we're just getting these from these numbers here. There's 3, 8, 4, 16. That's going to be 4, 16 somewhere way up here. It's off the charts. And this graph is going like this. And this is what we call an exponential curve or an exponential function. So here's 4 different types of functions. Okay, linear, which you've seen before, and quadratic, square root, and an exponential, which we'll be working with. Okay, but what we see here, this is how you graph an equation. If you kind of understand an equation, you can make a table out of it. You can plot the points, and you can draw the line or the curve that matches it. Okay, that goes through those points. That's how we graph any basic function, whether we know what to expect or not.